So we are going to do combined and composite functions. We're going to start with combined functions. That just means that you are going to add, subtract, multiply, or divide two functions together. You're going to add, subtract, multiply, or divide two functions. And you guys have very good algebra skills, so you're going to be just fine with this. This is like the tedious but not difficult stuff, okay? So we're going to use these two functions, f of x and g of x. F plus g. Literally, you are just going to add them together and combine the like terms. I'm going to just talk us through it so we can just write our answer. You add these together. 2x squared does not combine with anything over here, so it's just going to be 2x squared. And then what do you think? Plus 4x, good, you're just adding those together. And then minus 1 and minus 4, good, minus 5. That's it? Yep. You're just adding them together. Now, subtraction, I want you to write out the middle step because negative signs are the most commonly missed thing ever, and we want to keep track of our negative signs. So f minus g, you're going to have all of f of x, so just copy that over. Again, humor me. Don't try, Miss Cole, I can do it in my head. I promise you, negative signs are the most commonly missed thing ever. That's my pep talk for that. Like, don't be too proud to write it down. Now, minus g, that means you are going to subtract both terms there. So it's going to be minus x and then what? Plus 4, good. You would distribute a negative to both of those. Basically, they're both just opposite. And then put your like terms together. So it would be 2x squared. Good. Plus 2x plus 3. Good. Heard somebody whisper it back. This one is not the same as this one. And when it's subtraction, I want you to write it. It's 2 whole steps. Like, humor me. I'm not asking for a whole lot. Write it out because you will be upset if you drop a negative sign. Like, if you get a quiz back and you missed a negative sign, you are going to be upset. So just write it. All right, so g is this one, x minus 4, and then it's minus f. So you have to distribute a negative through this to subtract the entire thing. So it's going to be minus 2x squared, minus 3x, and then plus 1. Good job. And then put it together. Just write out that one step. It only takes a few seconds, all right? Are you guys you like to have the squareds first, like when you want it in order? Okay, so negative 2x squared. Some people don't care, and some people are like, no, it must be in order. I like for it to be in order too. All right, and then your x's, it would be negative 2x and then negative 3. So I want you to look at these two answers and tell me what you notice. They're opposites of each other. You see that? Okay, and that makes sense, right? Logically, that would make sense. All right, this little dot means multiply. So you're going to do f times g. So here's what I do for this. I would take the x, distribute it to everything, and then take the negative 4 and distribute it to everything. How many terms are you going to have in a row? It's going to be really long, but how many things should there be? 6, because 3 times 2 with me there? Okay, some of you are already writing it. All right, distribute the x through there. That's going to be 2x cubed plus 3x squared minus 1x. And then you're going to distribute a negative 4. So it would be minus 8x squared minus 12x plus 4. And then like terms together. So that would be, oh, wait, what happened? Are we all good?
No, I was like multiplying what we got for when we times it by x and multiplying that by negative.
No, you distribute the negative 4 to all 3 of those. All right, so let's see, how many x squareds would we have? But if you put them together, yeah, minus 5x squared. Good, and then minus 13x plus 4. Again, this isn't hard. It's just like tedious, and you have to watch your negative signs and, you know, like just be careful because there's a lot of things there. All right, and then division. What number is going to go in the little box off to the side? We're doing f divided by g. 4 goes in the little box. Your countdown is in order, 2, 3, -1. Will the remainder necessarily be 0 here? No, it's just going to be whatever it is. It'll just come out to whatever it comes out to. So you bring the 2 down, multiply, add, until you get to the end. So 4 times 2 is 8. Add, you get 11. 4 times 11 is 44. And so our remainder is 43. So did not work out perfectly, obviously. And then when you put the x's back in, it's going to be 2x plus 11. And do you remember how to tack on?
Plus 43.
Good. And that is called the divisor. So it's your remainder over your divisor. So here's what's going to happen. Oh, wait, question. Go ahead. Okay. I'm going to hit pause on the recording. If you're watching this at home, it won't feel like any time passed. I'm going to hit pause. I'm going to have you guys try this one, and then I'll give you the answers and we'll check.
All 5.
So I just wrote up the first 2. Did we check those and you agree with me?
Yes.
Okay. So when I go to do number 8, I know it is just going to be the opposite of this one. So I can just go ahead and write positive x squared minus x minus 3. So if I just look at this answer, I know this one's going to be opposite. All right, multiplying. I'm going to distribute the x to everything. So negative x cubed plus 2x squared plus 4x. And then if you distribute a 1 to anything, like it's not going to change. So just that stuff. Go ahead. Yeah, I distributed the x to all 3 of these, and then I'm distributing a 1 to all 3 of them, but if you multiply through by a 1, it doesn't change, so I kind of just recopied the problem. All right, and then like terms, so we've got 2x squared minus 1x squared, that's just going to be x squared. 4x plus 2x is 6x, and then plus 4. And then when you divide, what number goes in the little box off to the side? Yeah, -1. Our countdown is in order. I got -1, 3, 1. Okay, bless you. So it's -1x, or just negative x, plus 3. And then your remainder goes over the divisor, which was x plus 1. Are we all basically okay? Or if we had like 1 or 2 tiny issues, we fix those. Here. So we just did the combined functions, which you add, subtract, multiply, or divide them. A composite function is where you take one function and actually put it inside of another function. So it looks like this. I always say it's like F got hungry and ate function G. They're not being multiplied together. Why do you have your Chromebook out still? They're not being multiplied together. One is getting placed inside of the other. The way that you also sometimes see it, which Delta Math does it, is like this. I really don't like that as much because it's more difficult to see which one is the outside and which one is the inside. So if you see it that way, I would write it like this. F is outside, G is inside. The way this relates to the telephone game, and the reason that I go through doing this is because it helps people understand what's actually going on. You start with an input, like a number, like 5. You input it to the inside function, and that function changes it, just like you changed the sentence. You get a new output, and that gets passed along like the telephone game to the next function, just like you pass the new sentence on to the next person. Do you understand what I'm saying? You have an input, it gets changed. You pass that new number on to the next function, okay? So let's go ahead and do these with numbers. Now you're going to have to listen because there's not a whole lot of work that gets written down here. You kind of just, you write like one step and then you get the answer. You would start with function, which do you think on this one? G, you would start with G. You're going to do G of 4. You ready? Yeah. This one's G. We're going to plug in 4. You plug in 4, what do you get? 9. 9 is going to get passed along to function F like the telephone game. That's the only work. So I really want you to write it because if your answer's wrong, I can't do any partial credit unless you show me that step. So we inputted 4. It got changed to a 9. Now we're going to pass 9 along to function F. So if you plug 9 in here, 9 squared, 81 minus 7, 74 is your answer. Let's try it again. Which function are you going to start with, f or g? You're going to start with function f. Good. You're going to plug in -6. Here we go. -6 squared. 36, thank you for not saying -36. Positive 36 minus 7 is 29. 29 gets passed along to function g, like the telephone game. You pass it along to the next function. Each of you was a function. And then you're going to plug 29 into function g. If you double 29, 58. Just think of doubling 30 and then readjust it. So 58 plus 1, 59 is your final answer. Now you can plug it into the same function again. It's sort of cannibalistic, all right? You're going to plug -2 into function f. Here we go. -2 squared. 4 minus 7, -3. And then you're going to plug -3 into function f again. So -3 squared, 9 minus 7 is 2. Now you can do the same thing with graphs, and it's even easier because you don't have to do any actual math. You just have to find the point on the graph, which means you're going to have to look, because I don't have a better explanation than, hey, there it is. Like, you're going to have to just watch me point to it. Are we going to start with f or g for this one? G. Okay, we're going to do g of 1. You ready? You're going to, oh, sorry, -1. You're going to find -1 on the x-axis. You see how it's right here? All right, you're going to see where that hits the graph. It hits the graph at 1. 1 is what gets passed along. Please write this step. It's the only work that there is. So now we're going to go to function f, which is this one. You're going to find 1. Where does 1 hit the graph? -2 is your answer. It's very simple, but you have to know how to read a graph. All right, so this one, and now you guys are at the point where you're going to be working ahead of me, which is fine. Just make sure your answer's right. G of 0. So I'm going to start with G over here. G of 0 is 0. That can happen. 0, 0 is a valid point, right? So it's still 0. You're going to plug 0 into function f. Where does 0 hit the graph? -1 is your answer. Now we're going to start with f for this one. F of -3. So you're going to find -3, which is right here. See where that hits the graph. Where does -3 hit the graph? 2. Good. You're going to pass that along like the telephone game. G of 2. So you find 2, which is right here. See where it hits the graph? At 4. Cool? Telephone game. All right. Now this last section. We're not plugging in actual numbers. It's f of g of x and g of f of x. So this is going to involve some algebra. It's tedious, but not difficult. All right. We're going to find them both. That means you have to label. If you don't label, I don't know which one is which. All right. So you have to write that. Which function is getting plugged into which for this one? Yeah. So g gets plugged into f. Don't draw these arrows because I'm going to have to erase them, all right? I'm going to take this, plug it in over here. Just like in the telephone game, you know how you removed a word and replaced it with a new word? We're going to remove x and replace it with like all of that, okay? And if there was more than one x over here, you would replace both of them. Do you understand what I'm saying? Because delta math will do that. Like say it was 2x squared minus 5x. You would replace both of them, okay? So it's going to be 2, and then x minus 7 squared minus 5. And then you have the tedious job of multiplying that all out. But we've done this before, and you guys were good at it. When it's x minus 7 squared, that means you should write that twice. It is a twin. And then you're going to have the 2, just wait patiently. X times x, x squared. Do the outsides and the insides. Minus 7x, minus 7x. Minus 14x, very good. Plus 49. Again, you guys have been very good at this. You guys know your times tables and you're very good at your algebra. All right, and then last step here, we're going to distribute the 2. So 2x squared minus 28x. If you double 49, just think of doubling 50 and then bring it back a bit. 98. And then you have to subtract 5. So 98 minus 5 is 93. That's your final answer. Now we're going to do it the other way. And it's not going to turn out the same. And you have to label g of f of x. You have to label that because they're different. So you have to know which one is which. So this time, which gets plugged into which?
The 2x squared minus 5.
Yeah, f gets plugged into g. Now, usually one way is a little bit more tedious and then the other way is really easy, okay? You take all this and plug it in for x. You're just going to have all that stuff minus 7. That is a much easier problem because what's the only thing you have to do? Yeah, combine them. So it'd be 2x squared minus 12. And I'm going to bring up for everybody because I heard you talking about this over here and asking it. We don't factor them. We don't set them equal to 0. We don't do anything else with them. Please just stop. That's your answer, okay? Like, don't do any more work. We're just going to practice this a couple more times. No, and you did this last year. Do you remember this from last year?
She just made everything super hard.
Okay, well. All right, f of g of x. Again, you felt that way last year because it was the first time you saw it. This is the second time you're seeing it, so it's going to seem easier. Do you know what I'm saying? Like, that's the way that's going to work. All right, for this one, g gets plugged into f. Again, don't draw these arrows because I'm going to have to erase them. I don't want you to mess up your paper, all right? So all of this gets plugged in right there. That's going to give you square root of x plus 3 squared. Now, this is the $1,000,000 question. Does the squared and the square root cancel or not?
Yes.
It does because you have square rooted the whole thing. Do you see what I'm saying? So the whole thing. So those do cancel and you get x plus 3. But wait, when you go to do it the other way, I will show you, it's not going to work, which is actually nice because it's less work that you have to do. Label, you're going to have g of f of x, and now f gets plugged into g. So it's going to be square root of x squared plus 3. Do you see how the squared is only on the x, but not on the 3?
Yeah.
So you can't do anything to that. They don't cancel. You can't cancel just part of it, which again is great because then you don't have to do anything. But it is like, wait, when do I cancel and when do I not? It's when it's the whole thing, okay? Let's try it again. F of g of x. And yeah, I'm sorry, you have to write it. Like, they're different. I don't know why I keep pep talking that. No one's giving me a hard time. Sometimes I get people that complain about it. So I'm always like, you can do it. All right, g gets plugged into f. So all of this gets plugged in over here. So you're going to have square root of 1/3 x squared minus 8. Does it cancel or does it not? No canceling. The squared is not on everything. So that's great. That's your answer and you're done. All right, now for g of f of x, f gets plugged into g. And so that's going to be 1/3 square root x minus 8 squared. I removed the x and replaced it with this entire thing. Now, is that going to cancel or not? Yes. Now, that one does because the square root is over the whole everything, all right? So you have 1/3 x minus 8, and then you actually have one more step there. Yeah, and it's just going to be 1/3 x minus 8/3. 8/3 doesn't reduce, so you just leave it alone.
Can you just do x minus 8 over 3?
Yes.
Okay, just that. I just want to.
He always goes fancy. It's not wrong. Don't worry about it. That's fine. I just need to not lose the rest of my class. All right, f of g of x. I'll explain it once I stop the video. All right, so g gets plugged into f. What is that going to give you? 1/x plus 6. Is there anything you can do with that? Nope. Life is good. Honestly, takes longer to write f of g of x than to like do the actual problem. All right, g of f of x. Now f gets plugged into g. It is a very subtle difference. They are different. What would this one equal? It's not the exact same thing.
One is only over the x.
One is only over the x, good, and then plus 6. As a foreshadowing, next class we're going to do the domains of these, and so that's they turn out different, okay? One more of these. You got it. You got it in you. You can do it. All right, so G gets plugged into F. That is gonna give you 1 over absolute value x plus 3. So all of that plus 2. Now here's the $1 million question with this one. Can you add the 3 and the 2 and get 5 or not? No. This is inside the absolute value, and that is not. You cannot combine them together. Other way you can think of it is left 3 up 2. Do you get what I'm saying? Like your transformations, you can't combine a left 3 and an up 2. Like if you want to think of it, that's not actually what it is, but if you want to think of it that way, one is inside and one is outside, so you cannot put them together. All right, and then G of f of x, F gets plugged into G. So what is that gonna give you? Absolute value bar, and then 1 over x plus 2, like all of that gets plugged in there, plus 3. Can those get combined? No, this one's inside of the fraction and that one's not. If you want to give this a hug to help you remember to keep your hands off, but you just aren't going to do anything. Now I like these ones. You're separating it. It's like good for your brain to do this. We want to find what are the two different functions if this is your answer. And we want f to be the outside function and g to be the inside. G is like the guts of it, the inside stuff. So I usually do g first. G is the guts of it. So g would be the 2x minus 9. Do you see what I did there? Like I just took this stuff. Now I want you to think about it. What would function f need to be for this to be your composite function, for this to be the answer? 1 over x. Good job. You took this and plugged it in for x, like substituted it in. That's what you would get. So g is like the guts of it, like the inside, and then f is the outside function. Go ahead.
I was just saying, where do you?
Oh.
Yeah, g of x is going to be like the insides. Here, let's do it again. I kind of like these, like separating it out. What would g be? Like don't overthink it. What's the insides? Yeah, 5x plus 7. Good. Like, yeah, don't overthink that part. And then what would function f be? Like, what did you plug? Square root of x. Good.